Experiment number 1. The power of bubbles. Effective catalysis and chemical reaction rate. Materials: 2 plastic bottles, warm water, yeast, sugar, 2 balloons, and teaspoon. First, prepare 2 empty bottles and label the first bottle with yeast and the second bottle without yeast. Next, put 2 teaspoonfuls of sugar to each of the bottles and 3 teaspoonfuls of dry yeast to the bottle with the label of with yeast. Then, slowly pour the warm water to the 2 bottles. Put the balloon over each of the bottles and wait for half an hour. Catalyst is a substance that enables a chemical reaction to proceed at a usual faster rate or under different conditions. It is an agent that helps the reactants in a chemical reaction react with each other. Yeast acts as a catalyst in this experiment, as it is a microorganism fungus that converts sugar into carbon dioxide. This means that if we mix yeast with sugar, it consumes sugar to produce tiny bubbles of carbon dioxide. And for the yeast to be active, it needs to be warm and moist. That is why we added lukewarm water. What if I put cold water instead? Well, I tried and yeast did not react. It is in a state of rest. Because we put party balloons in the opening of the bottle, the gas was trapped in the balloon, making it inflate as if by magic. Experiment number 2. Matchstick soaked in water. Effect of temperature on chemical reaction rate. Materials: matchsticks, water at room temperature or tap water, cold water or ice water, and lighted candle. First, soak a matchstick in a water at room temperature for 1 minute. Place the matchstick over a lighted candle, enough to lit it, and observe the intensity or color of the lighted matchstick. Next, soak a matchstick in an ice water for 1 minute. Place the matchstick over a lighted candle enough to lit it and observe the intensity or color of the lighted matchstick. This demonstration shows the effect of temperature on reaction rate. Raising the temperature of reaction mixture results in both more frequent and more energetic molecular collisions. Increasing the temperature increases the average kinetic energy of the molecules. At higher temperatures, molecular collisions are more likely to have enough energy to form products. This increases the rate of reaction. At lower temperatures, there are fewer collisions and most of the collisions do not occur between reactants because they don't have sufficient energy to form products. At elevated temperature, the increased reaction rate can be perceived as increased brightness of the light being given off by the fire of matchstick. At cold temperatures, the matchstick glows less brightly because in a given time period, fewer reactant molecules are colliding with sufficient energy to form the products.